Webb Floyd, briefing on behalf of me this time. I'm the FOD cover guy. So at this training here, we're going to look at installing the FRP cover as well as inspecting the cover during its lifespan. So FRP is a FOD cover. It's an expedient pavement repair system. It's modular in nature for covering craters of different sizes. It's compatible with a wide range of backfill materials, and in most cases, the quality of that backfill material is going to dictate the lifespan of the repair or how often you have to come back and do maintenance. Next slide, please. Just raise your hand if you have not handled FRP before. Most of the group is handled. That's good. So, safety first, gloves, boots, ear pro, eye pro, lift with your legs. When you're drilling the holes for the anchors in concrete pavement, you're generating silica dust, and you should also be wearing an N95 mask to protect your lungs. You don't want to inhale that silica dust. There's a list of all the different pieces of equipment, small power tools, hand tools, those types of things that are in your kits. In the Army ADR kit, you have all of these things. The Air Force has them all in their FRP panel kit. They're also in the Marine Corps ADR kit attached to the Marine Wing Support Squadrons. Next slide, please. So just some general FRP guidelines here. We're looking for at least 1 foot overlap in all directions onto sound pavement. The angle of the cover with respect to the direction of traffic should be no more than 5 degrees askew, and we're not going to get protractors out and measure that. It's a judgment call by the team lead. Once the cover's in place, you're going to look down the direction of flight, put your hands out, clap a 90, look at the angles, see if it's close, make adjustments if need be. Don't get a ruler out and look down to the nearest 16th of an inch. It's a judgment call. When there is a primary direction of flight, if it does exist, most of our airfields are going to be bidirectional, but if there is a primary direction of flight, we want to place that row of anchor panels on the leading edge of the FRP cover, and we're only going to anchor the leading and the trailing edges of the cover, not the outside edges. That lets the cover expand and contract under aircraft loads as well as under thermal loads from the sun. It's going to shrink and swell based on the temperature. We're going to place the cover such that our anchor bolts are at least 6 inches from a concrete joint or any significant cracking. You can shift the cover front to back, side to side to accommodate that spacing from the joints in concrete pavement. You can also, if you're unable to avoid those joints, there are hole saws and mandrels in the kit. You can punch a new anchor hole in the mat. And there's a great Air Force document there that's mentioned at the bottom that has all of their interim TTPs for installation and maintenance of the FRP system. Available by request from me or the Air Force Civil Engineering Center. I believe you can probably send an email to the AFCEC reachback email address, and they'll supply you with a copy of the TTPs as well. So there's several ways you can get it. Next slide, please. So FRP panels, there's 4 types of panels: full-size panel, half-size panel, full-size anchor, and half-size anchored panels. The full-size panel is like 16.5 feet by 6 feet, somewhere in that range, 208 by 78 inches, weighs 400 pounds. It's a 6-person lift. You want to do 1 person at each corner and then 1 person on the sides and the center to help lift. The half-size panel is exactly half those dimensions and half that weight. It's a 4-person lift. Full-size anchor panel is 200 inches long by 24 inches wide, weighs about 150 pounds. So that's technically a 3-person lift, but you can do it with 2 and drag the center. You're not going to hurt these panels by dragging them around, so you can drag the anchor panels where they need to be. So the anchor panels transition from the underlapping edge of the mat, which has the lower joining bushings pre-installed. You can see an underlapping edge there on this photo, and you can see the top of those lower joining bushings, the silver circles show up. All the anchor panels do is provide a stiffened surface that transitions from those underlap edges with the lower joining bushings to an open hole edge for anchoring. Next slide, please. So we got 3 different types of bushings associated with FRP. On the left, we have a joining bushing, also often called a connector bushing. In the center there, we have a lower joining bushing. And you can see how those 2 bushings come together to make an assembly and sandwich an overlapping part of the mat with an underlapping part of the mat. And then on the far right edge there, we have an anchor bushing. That's a bushing with an open hole that receives an anchor bolt, either a concrete anchor bolt or an asphalt anchor bolt. Next slide, please. So layout options. So when we purchase FRP from the manufacturer, we purchase it on a per assembly basis. And one assembly is 7 full-size panels, 6 half-size panels, 3 full-size anchor panels, and 4 half-size anchor panels. And it can be configured to cover one 28-foot crater, or 3 15-foot craters, or 5 10-foot craters. So again, it's modular. You can cover different sizes and shapes of craters with one matting system without having a whole lot of wasted material around the edges of the crater. That's the beauty of this system relative to some of the older FOD covers, which are more of a, let's unfold this giant mat that covers maybe a smaller crater. We have less waste here. It's a little bit more agile. Next slide. So assembly of the FRP cover. This is a standard full-size assembly here. You can see that it has marked a leading edge and a trailing edge. So on this picture here, traffic would be up. We've got a leading edge and a trailing edge with the traffic going upwards, and the panels are numbered according to the installation sequence. So we're going to start on the right-hand edge of the right-hand corner of the trailing edge. There we see panel number 1, and then place right to left, row by row, coming towards the leading edge in a brickwork fashion. You can see where there between the first row of the trailing edge and the second row, none of those joints looking longitudinally down the direction of traffic are following the line. They're offset just like a standard brickwork pattern. So again, we're going to start on the right-hand corner of the trailing edge, row by row, brickwork fashion, working our way towards the leading edge of the mat. As we do so, we're going to install our joining bushings or our connector bushings by hand tight, in each row as we go forward. And when we get in the field tomorrow, we'll talk about the appropriate sequence to install those, just to make life a little easier for you. Again, we're only installing those hand tight. Once we have them all installed, we're going to come through with an impact wrench and torque them down to 110 foot-pounds. There is one error on this slide though. If you look at the row of anchor panels and that first row of full and half panels there, it's not in the brickwork fashion. So here we would have preferred to have had 2 full-size anchor panels rather than a half full, half to stay with our brickwork convention. 110 foot-pounds of torque, and that's for all of our connector locations as well as all of our anchors. All the connections and all of the anchor bolt heads are all 15/16 of an inch. So you don't have to change out sockets or anything like that. Next slide, please. So I think that all the craters we have in the JDARS pad are 8 to 10-ish feet in size. That's
6 and 8.
6 and 8. So these are probably the layouts we're going to stay with when we're on the actual pad. When we're training FRP tomorrow, as we cycle through our round robin, I think we're going to have some space to do some larger assemblies. But when we're on the actual pad working, we'll be in one of these 5 layouts. Once you step up from beyond a 12-foot diameter, that's when you're going to need to start adding that third row of panels to accommodate that minimum 1-foot overhang in all directions. Next slide, please. So for the team size on this one, we like a team lead, somebody who's directing where the panels are going and ensuring that every bolt and bushing is torqued sequentially in a, let's say, systematic manner, and we're not jumping around tightening random ones or we may miss one. We want to go row by row in a very deliberate manner to make sure that everything is tightened and everything is meeting the installation requirements. And team members, we have 6 plus to work with that lead because the largest panel is a 6-person lift. You probably are going to either want an opportunity to rotate team members in and out, or more than 6 team members if you're going through a multi-crater sequence, because these panels are a bit cumbersome. Next slide, please. So anchoring, there's 2 approved anchoring systems currently. For concrete pavement, there's the power bolt, the expansion bolt, 06957SD is the model number there. It's a standard rock bolt. So from the left to the right side of the bolt, on the left side you have the bolt head and a washer, and then you have the upper part of the expansion sleeve, a sacrificial plastic ring, and the lower part of the expansion sleeve. So when you sink that bolt in the anchor hole and you apply torque to the top of it, it draws up that wedge-shaped anchor on the right side of the base of the expansion sleeve, expands it out, and secures it to the sides of the anchor hole. On the bottom there, you see the tri-talent anchor, which is the currently approved asphalt anchoring system for FOD covers. And it is 22.5 inches in length, where the concrete anchor is only 8 inches in length. That 22.5 inches in length allows you to take advantage of that full asphalt pavement structure, and not just the top 3 or 4 inches that is the asphalt portion. Asphalt doesn't have good lateral load bearing capacity, so if you were to use, say, an expansion type bolt in that asphalt, while it may meet your torque requirement at the beginning and give you some okay pull-out resistance, that asphalt is going to slowly and constantly flow under load, and you're going to lose that resistance. So we'll look at the cross-section of that tri-tile anchor in a minute. Next slide, please. So FRP anchoring in concrete pavement. We are going to use the anchor bushing as a guide, and the leading and the trailing edges of the cover. We're going to drill a 3/4 inch diameter hole to a depth of approximately 10 inches. We're going to wear a dust mask while we do that to keep us from inhaling those silica fumes that we generate in the dust with concrete. We're going to use a spotter while we drill to make sure that we're drilling plumb, both longitudinally and transverse. The bolts don't perform as well if they don't go in square. After we drill our hole to a minimum depth of 10 inches, it's pretty good practice to just wrap a piece of electrical tape or make a mark on that bit so you know when you're getting close to 10 inches and we're not having to measure each hole or estimate. We're going to use compressed air to blow the debris and the dust out of that hole. We're going to clear anything that accumulates under the edge of the FRP cover during the drilling process. We're going to replace that anchor bushing on the hole. We're going to sink the anchor with the engineer's hammer or with a sledgehammer. And we're going to deploy with an impact wrench. Check final torque with the torque wrench set to 110 foot-pounds. Next slide, please. You can see some photos of that process here. It's not overly complicated. We're going to drill the anchor hole on the left. We're going to use compressed air to blow debris from the anchor hole. Sink the anchor. I prefer a 3.5 pound engineer hammer like that rather than lugging a sledgehammer around. Deploy the anchor with the torque wrench, an impact wrench, and then check final torque with the torque wrench. Next slide, please. So this is a cross section of a tri-tile anchor installation here. Again, it's 22.5 inches in installed length. You can see that it extends well into the sub-base course. So we're beyond our asphalt pavement, our crushed stone subgrade, and we're down into our crushed stone base course, and we're down into the dirt, into the soil. Next slide, please. So it's a lot bit more involved installation process, but the anchor does work. This particular anchor is really driven by the mixed traffic challenge. I was just talking to the gentleman from PACAF about this earlier, but it's if we only had fighter aircraft on an airfield, we wouldn't need this anchor. If we only had cargo aircraft on an airfield, we wouldn't need this anchor either because we wouldn't need fog runners. It's truly a mixed traffic problem that drove this tri-talent anchor solution. The C-17 and larger aircraft are just not compatible with the legacy polymer plug anchor system where you're drilling a smaller hole, filling it with epoxy, and dropping one of those concrete anchor bolts in there until the epoxy sets. But that's a pretty decent anchor for fighter aircraft. Anyways, installation of the tri-talent anchor, we're going to drill a 2-inch diameter hole through the leading and the trailing edges of the cover. We're going to use a 2-inch diameter soil auger to auger to a depth of 22.5 inches. We're going to clear any debris or dirt that accumulates under the cover while we're drilling. We're going to separate the tri-talent from its coupler. We'll go through all this tomorrow when we're in the field. We're going to take the coupler off the talent, and we're going to drop the talent assembly with rod into the hole. We're going to slide the set tool over that and deploy it with a sledgehammer, reattach our coupler, and then we're going to mix rapid setting grout and fill that whole column with the rapid setting grout material, and then reattach our anchor bushing just hand tight until the grout sets. Next slide, please. We'll look through some photos of those steps. So we're drilling there on the left. We're augering. Second picture. Third picture, the soldier's dropping the tri-talent into the hole with the coupler having been removed. Fourth picture, he's deploying the talons by striking the set tool with the hammer. Next slide, please. And here on the left, he's using an electric impact wrench to reattach that coupler and run it down flush with the asphalt pavement surface. Mixing the rapid set of grout in the second picture. Pouring the rapid set of grout in the third picture through a transmission funnel into the hole, and applying final torque in the fourth picture once the grout is set. Next slide, please. I think that's it. Any